So hi, I'm Niels. As Maxime already told you, I was here last year. I'm so happy to be back. So how many of you saw my talk last year? A couple of people, yeah, great. So it was about connecting hardware to the web and about web Bluetooth, and there were a lot of hardware demos. And doing hardware demos is always crazy scary. Anything can go wrong. Somebody might hijack your drone. Thank you, Johannes. So this was my heartbeat last year. So live on the screen using a Bluetooth heart rate monitor, it's about 140. That is pretty high. But today we're going to go one step further. We're not only going to demo hardware, we're actually going to create hardware. We're going to program hardware live here on this stage, all using JavaScript. So last year, after the conference, a couple of speakers went on a little trip to the Troms area to watch the Northern Lights, and it was amazing. On the way back, though, we had a little accident. We hit a patch of ice, and the van started skidding across the road, and we ended up in a ditch. And everybody was all right, no problems. The funny thing is, I was wearing a heart rate monitor at the time. And I have a recording of my heart rate during the accident. It didn't go over 80. So giving a talk with hardware demos is 140. Being in an accident, having your life flash before your eyes is 80. So I don't want to even know what my heart rate is right now. Anyway, as Maxime told you, I'm Dutch. I'm from the Netherlands. Some people call it Holland. Those people are wrong. Well, you definitely heard of the capital, Amsterdam, which is famous for its famous canals. And often when I fly out to a conference like this from Amsterdam, well, there will be sniffer dogs waiting for me at the airport, waiting to see if some tourists brought some of those canals with them. And just to be clear, I am a Mozilla TechSpeaker, and I am a Google developer expert. And I want to thank Google so much for having or flying me out here. I tweeted HTML5 test, and I love the web. I've been a web developer since 1994. I've written my first HTML 25 years ago. Yeah, I'm old. And I love HTML, I love CSS, and I've even grown to love JavaScript. And I love electronics. When I was a teenager, I had this cardboard electronics set with wires and springs and components. And you could clip the wires between the springs and create a circuit. And you could build a radio or a Morse code transmitter. And nowadays, I have this. Still a lot of components and wires to connect together. And the components have become a lot more advanced. Instead of transistors and diodes and resistors, you now have microcontrollers and all kinds of sensors. But still, everything works together. You can clip stuff together with wires, and it still works. Now, I know some of you are thinking, why should I care about this? I am a web developer, I'm a mobile developer, I don't have anything to do with electronics. And you're right. But when you connect devices to the web or to your mobile phone, you get the Internet of Things. And you get devices that talk to servers and even directly to browsers, and there things start to get interesting for web developers. Now, first of all, a little bit of knowledge about IoT and connected devices is very useful, because these kinds of devices will only become more pervasive. There's a good chance that you will encounter this in your job in the future. Well, maybe not programming devices, but building apps and interfaces that talk to devices. Technologies like Web USB and Web Bluetooth are being rolled out in browsers right now, and it makes sense for us to know about that. But it's also very extremely interesting because there's a lot of engineering towards connected devices right now. This is where technological innovation is happening extremely fast. And if you want to know about cutting-edge stuff, this is the place to be. And finally, it's also a lot of fun to play with this technology. And even if you will never use this in your day job, it's just an amazing experience to build a web app, to, let's say, talk to a microcontroller, to drive around a toy car. Now, the main issue I've seen when web developers start playing with microcontrollers and IoT is the barrier of having to learn C. Now, C and JavaScript might look quite similar syntactically, but it's a completely different beast. Yeah, you not only need to learn C, but also low-level programming concepts like memory management, pointers, and even though I learned this back in school 25 years ago, yes, I'm a dinosaur, I hate this. Now, what if we could use a language that we already know? What if we did not need to worry about those low-level concepts? What if we could use JavaScript on microcontrollers? And not only that, what if we could leverage the browser to connect these microcontrollers and let them extend each other's capabilities? Now, this is all fine and well, but microcontrollers are slow. They are really, really slow. And when I say slow, that doesn't even convey the idea of how slow they actually are. They are slow. Now, take, for example, the slowest computer you can buy today, the Raspberry Pi. And this is the 0W, which is the slowest Raspberry Pi they make right now. Well, they are all slow, but this is really, really slow. It's still a great little computer. You can run Linux on it and Node.js and can run a browser like Chrome or Firefox. But it's a computer. This is not a microcontroller. So this is a microcontroller. It's a little board created for school children, and it runs just at 16 megahertz. And it has only 16 kilobytes of RAM. And it is slow. But it's not even by far the slowest microcontroller that you can find. But this one can run JavaScript. Now, this is the Raspberry Pi. It's about 60 times faster than a microbit. It's about 30,000 times more memory. So the microbit is on a completely different level. Now, when I started working with computers 32 years ago, back in 1987, I am old, we had an Apple Mac Plus. And it was a fantastic computer back at the time. And I learned programming on it. And even back then, I loved it. It booted up from a floppy disk. And after a couple of minutes, you could remove the operating system floppy and insert an application floppy, and then start the application. And whenever the app needed something from the operating system that wasn't already loaded in memory, and the memory was really, really tiny, so that happened all the time, then it would eject the application floppy. You had to insert the operating system floppy again, and vice versa. It was awful. And it was amazing and fantastic at the same time. Now, this 30-year-old computer is more advanced than the microcontrollers we're working with. Just to put that in perspective. It's probably about as fast as a microbit. Definitely has more memory. It has a whopping 1 megabyte of memory. So my microcontrollers doesn't have that. So here we are 30 years later, and we're going to run JavaScript on something less advanced than this thing. So are you crazy? Well, 2 years when I started playing with this, I would have said yes. But there are very good reasons why running JavaScript on microcontrollers it's actually brilliant. So JavaScript is easy, well, compared to C. So 2 years ago, when I created a gadget for showing notifications on my home automation system, I created a display with 8 by 8 pixels, and whenever I get mail, for example, physical mail, actual letters in my mailbox, it shows me a little icon of a mailbox. Like this. It's actually a ceiling light that I improved. I stripped out its guts and replaced it with a microcontroller. This first version was actually written in C. It took 877 lines of code, and that's excluding all the libraries I had to use. And we're going to recreate this project today in JavaScript in 30 lines of code. So that is the power of JavaScript on microcontrollers. Now, microcontrollers are very power efficient. You can run JavaScript on a tiny little Bluetooth-enabled board and power it using a coin cell battery. And it can run for months. So slow is actually a good thing, because when we make things faster, they usually require more power. And microcontrollers are fast enough. Yes, they are slow, but we're going to solve very small problems. Microcontrollers are fast enough for anything I'm going to show you today. And finally, they do not need an operating system, not in a traditional sense anyway. That may sound bad, but actually fantastic, because when I flick the power switch, I do not want my Linux-powered lamp to take 45 seconds to boot before the lights turn on. So that is, it is a good thing. Now, let's take a look at how we can get JavaScript on microcontrollers. So there's a lot of different projects in various stages of maturity, and I'm supporting different types of microcontrollers. But I'm going to focus on just one. It's called Espruino, and it's an open source project. And you can buy hardware in a store with Espruino already installed, or you can download the software and flash it on your microcontroller yourself. So it is really a cheap option. You can get a microcontroller with Espruino. If you flash it yourself, you can get it for a couple of euros, maybe 5 or 6 euros. You're done. You can buy this in a regular electronics store. Now, Espruino is an interpreter. That means it's not really fast. It has some ES6 features that are supported, like arrow functions and stuff like that. It has a REPL functionality, kind of like the console of a browser, where you can type JavaScript commands, and they are executed right on the microcontroller, so there's nothing in between. It's not like you compile JavaScript on your desktop and run the compiled code on the controller. No, you actually run JavaScript on the microcontroller. So you can connect the controller to your computer using a USB cable or using Bluetooth, and you can just execute commands on it, just like you would in a console of a browser. Now, it supports multiple types of microcontrollers, like the ones based on the ESP chipset family. It's built by Espressif. It's basically a Wi-Fi or a Wi-Fi and Bluetooth chipset that was used for adding Wi-Fi support to other microcontrollers. But it is a microcontroller on its own, and they created great little boards with it that are really, really cheap. So one of the boards that have an ESP chipset is the Node MCU. It's relatively famous in microcontroller land. It's about this big. It's not really tiny, but it's also not very big. And again, it's really cheap. You can buy it for a few euros from your electronics store, or even less from sites like AliExpress. And another chipset that is supported by Espruino is the Nordic NRF52 family, which is actually created by a company here from Oslo called Nordic Semiconductors. They're a little bit more expensive than the ESP. They're about 15 to 40 euros, depending on which board you want to buy. Like, for example, the Puck.js, which is a tiny button with a coin cell battery. Or the Pixel.js, which has a screen. I'm using that in this car. You can create little games on it, like the Chrome dinosaur offline dinosaur game. You can play that on this device written in JavaScript. It's also Arduino pin compatible. That means you can buy all kinds of Arduino shields like motor controllers, which is exactly what I'm using right there. The microbit, which is also Nordic NRF, but I would not recommend this because it is like an older generation, and it's barely enough to run JavaScript, so I would rather use something else. And finally, the Nordic Thingy, which is basically a sensor package created by Nordic and the same company that makes the NRF chipset. And it has an amazing amount of sensors and a button and a rechargeable battery and LED, all of which you can use and program from Espruino. And I have a couple of them with me to give away. So if you want to start playing with this, come up to me after the talk and I might well have one for you. With that said, it's now time for the demos. The fun part of this talk, I hope. So I do have some warnings to give. It's cutting edge stuff, hardware demos with experimental technology. Most of it using Bluetooth, a wireless connection, and Bluetooth has the same frequency of Wi-Fi, a lot of Wi-Fi devices here. So this is the moment where my heart rate goes up, and yeah. Okay. What are we going to create first? A connected light bulb. So we have a Pixel LED ring. Basically, these are 24 or something little LED lights, and they can generate any color you want. You can supply them with an RGB value, and the LED will give off that color. Right. It's connected with 3 wires to the microcontroller. And 1 wire is for power, 1 is ground, and 1 is the data that's going to be sent from the microcontroller to the Pixel ring. And in this case, we're using an ESP32, and I have one with me here. It's really tiny. You probably can't see it properly. Let's. Right. Here it is. Now, to get this working, we of course need power. All right. And then back. And it doesn't work. Nothing happens. That is actually the intention. This is not something going wrong. This is. I haven't programmed it yet. So let's try something. So we're going to define a color, an RGB value, just like you would in HTML or CSS. It's 6 hexadecimal values like FF9900, and you can exchange that for basically any color you want. We need a buffer. We need a buffer with 24 values of RGB, so 24 times 3. And that buffer is an array of bytes. It's a typed array, a uint8 clamped array. I didn't invent these names. Yeah. In that buffer, we're gonna put the colors. So we're gonna run over the buffer, or we're gonna make a loop for 24 iterations, and we're gonna set the RGB values in the buffer at a specific index. Now you'll notice that I'm not putting the RGB values there, but the GRB values. That is because the pixel ring requires the RGB values in that weird order. Yeah, just go with it. And finally, we're gonna require a library, the NeoPixel library, and we're gonna write that buffer to a pin. Now I've connected it to the D15 pin, the data pin, and now when I connect to this device and upload this code, it starts glowing. We've created a light bulb. Well, the beginnings of a light bulb. It still works. This is the first time I tried this. This was the moment I thought, this is just amazing. Just something I can write a couple of lines of JavaScript and the lights turn on. That blew my mind. So let's try something else. Let's replace this with buffer. So this is a little bit more complicated. So I have a buffer, and I'm using setInterval to change the value of that buffer every 16 milliseconds. And I fill that buffer with 0, so it's black, and then I add some colors. Let's just see what this does. So we've created an alarm, alarm for my house. So what this does is actually it writes a couple of red values, then it does nothing. It writes a couple of blue values, and depending on the iteration, it rotates it. And this is just 28 lines of code. So let's go back to our initial example. This, if I upload it, it's orange again. Now let's make that a function. We can now update our light, calling the update function. And this is basically the same thing. If I upload this to the device, nothing changes. It's still orange. But I can add some extra code. I can, on initializing the device, this function is called, And first of all, it calls the update function to make sure that a color is set. Then I start advertising this device as Esperino Light using the Bluetooth stack. I offer a couple of services. Now, I don't have the time to actually explain how Bluetooth services and characteristics work. If you want to know, my talk from last year, it's recorded and you can watch it. It goes into this in detail. But let's just say we're going to offer a service, a value that we can read and write to with a specific ID of a service and an ID of a characteristic. Now, these IDs are important. Those determine how I should write to it. But the value is the most important part. The value is readable, and the value is writable. And initially, the value is an array with the values of the RGB color. Now, when something is written to that value, I get a callback. And in that callback, I get an event, and the event data contains the value that has been written to it. So what I do is I extract those bytes from the array and set that to our color. And then I call the update function, and that means the color will be written to the pixel ring. Now, let's remove this. If I upload this, I should now be able to connect to it and change the color. Now, let's use this one instead. It's actually the same thing. Instead, it's just a pixel ring inside of a light bulb that I bought somewhere, took out all the components, and inserted a microcontroller. Now, this light bulb can be connected to from the browser using web Bluetooth. So I'm gonna call the request device API or function of the web Bluetooth API. And I add some filters which determine which device I'm going to connect to. First of all, I'm going to connect to an Esperino Light. That is the service we've been advertising here. And I'm going to say I'm going to use the FFFA service, which is this part. So whenever I execute this, a dialog pops up, and there is my light. I can connect to it. And then I have my device in JavaScript. I can then connect to the GET server. I can get the primary service, and FFFA, again, that is this value. And once I have the service, I can get the characteristic. This is FFFB, and that is this value. And now I have the characteristics, and now I can write a value to it. I call characteristic.writeValue, and I have a uint8 array, and I have a value of FF0080. So we're going to write an RGB value, a hex color. FF00 is, if I recall correctly, pink. Let's see. Pink. It works. So what I've done, I've written a lamp with 28 lines of code that I can connect to from the browser, and in 1, 2, 3, 4, 5 lines of code in a JavaScript, in a console of the browser, I can change the color of that light bulb. I can change it in any way you want. Doesn't matter. The values are you can basically create every color with these 3 values. You can even make black. Okay, not really black, but it turns it off. So this is pretty fun. So let's try something else. I've created actually a demo. I've used this demo last year too. Then I connected to some lamp you could buy in the store. Now I'm going to connect to my own lamp. You can use the browser to basically change the color. And so this is fun. You can actually do something else with it. Or use CSS. Nope. CSS animations. Now, this is actually cheating because the CSS isn't actually running on the microcontroller. It's actually running in the browser, and I'm just I have a div that I change the color of, and then I just frequently pull the color from that div and send that over to the microcontroller. So it is not. It is cheating, but still, I think this is just amazing. Okay, let's go on. So the next thing we're going to make, it's a Pixelart display. No, I showed it before with a little dinosaur, of a little mailbox on it. It was 877 lines of C code to get something on the screen. We're going to do that a little bit quicker today, because I don't have the time to write 877 lines of code anymore. No. So in this lamp is an 8x8 NeoPixel, again, grid. It's connected using independent power source to a Nordic thingy, 52. With some wires, the data cable goes directly to the NeoPixel display. I did solder some things on this to get some pins on it. I tried to make everything that you didn't have to solder. But even after maybe 30 years of not having touched a soldering iron, I could do this. So basically everybody can do this. I'm really, really lousy at soldering. And again, it's an old ceiling light. You can buy this for 10 euros at a do-it-yourself store. And I'm gonna program it. Let's see. Let's power it up. let's get rid of this. Now we need a, we need a different buffer this time. Again, RGB values, but we have a pixel that is a pixel array that is 8 by 8 pixels, so 265 times 3. We're going to have a function. That function takes a couple of arguments, the RGB value, of course, but also the position that we're going to write at, and it's from top left to bottom right. I'm going to set the color in that buffer at the position that we specified. I'm going to write that buffer then to, in this case, the D4 pin, which is connected to the NeoPixel. We need a function to clear the screen. We basically fill the buffer with zeros, make it black, and we write that to the pin. And just like before, we're going to advertise a service and advertise a characteristic with a value that we can write to. Now, the value in this case can start with either a 0, and we don't care about the rest of the value, and it will clear the screen. Or it starts with a 1, which means we are going to draw. We're going to draw. I'm going to use the second value of our data as the position, and the second, third, and fourth, it's indexed by 0, this third, fourth, and fifth, as our RGB values. And this is basically it. This is all there is to it. It's just pretty much the same as the light bulb, except we don't have one light bulb, we have 8 by 8 light bulbs. So if we upload this to the device and let's see, connect or Bluetooth. Let's per pixel. We've uploaded it. Now I can disconnect and use the browser to connect to it. There it is. And now we can draw something on it. And basically every pixel I draw on the screen is just one message with that data sending to the microcontroller. So for every pixel, the microcontroller only has to do very tiny things. If I write a pixel, it doesn't work. It doesn't work. Let's see. D4 pin, D4 pin, D4 pin. Let's try again. No, doesn't work. Well, if it would have worked, then it would basically just take that data from that one pixel and put it in the buffer and write that buffer, and then you would have the ability to write, basically draw anything on that screen in just 29 lines of code. Now, for time, I'm not gonna try to debug this live on stage because that would be really, really boring. And I have something far more exciting to show you. I have a car. Now, this is actually my son's car. I have a 5-year-old son, and he loves Legos. And I basically stole this. I'm going to drive this on this table. And I'm a little bit scared about this. Because if I destroy it, my son will be really, really unhappy. So let's try this. We're going to connect to it. And we're going to write some code. Now, to drive this car, we need a function. And we have the function drive is going to take 2 arguments. If you want to go turn on the left motor, we have a Boolean. And if we're going to turn on the right motor, we have a Boolean for that too. So if we want to drive forward, we're going to say drive true, true. If we're going to go left, we're going to say drive true, false. And right, drive false, true. To get this motor working, I have a motor board on it. It's connected to the motors and to the microcontroller. And it's using 4 pins. And to turn on a motor, I have to write a value to the D12 or the D13 pin. And to set the speed of the motor, I'm going to write a value to the D3 and D11 pin. Now, this is specific to this motor board. You can forget this. This is not important. It's just 4 lines of code to make this work. Now, to stop, we're going to send the power 0 to the D3 and D11 pin. We need some functions to go forward. I'm not using true and false, but ones and zeros, but that's the same thing. In this case, forward, reverse, right, left, and stop. This should do it. So let's try this. Let's go left. Ooh. I was hoping I wouldn't need to. It doesn't work. That is really annoying. It is connected to the... Is it connected? Now I know why it doesn't work. It's not connected to the car, it's connected to the pixel. That makes sense. Thank you. Okay. So this table isn't really suitable for... Stop. So I could show you forward and backwards, but that feels like pushing my luck. Let's make it remote controllable. Let's do that. Let's add another function on init. We're going to advertise again as our car. We're going to not care about reading the value. We're going to care only about writing the value. And we're going to write just 1 byte to the car. 1 byte is 1 command. And we're going to have a byte for forward, left, reverse, and stop. The values 77, 61, everything is okay. 73 and 0, or the first 4, that's actually the ASDW keys on a keyboard in ASCII value, and 0 is stop. So with this, we can create a demo that can actually drive the car. So let's try that. Let's connect to the car. And now we can actually control it using the browser. And every time we're just sending 1 byte to the car. Left, 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 right, 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 forward, backwards, yeah, you get it. Actually, there is something on this car that I didn't tell you about. There is a sensor on it. And that sensor is basically a laser that is pointing down towards the table, and it reflects back, and it measures the time for the reflection to get back. Now, if I am on the table, that time is very short. If I get near the edge, it goes all the way down to the ground and back. That takes much longer. So I could use that to detect edges of tables. So in theory, I could drive this car off the table and it will refuse to do so. In theory. So let's see how that looks like. We're gonna have a function to measure the distance. And if the distance is over 25 centimeters, we're gonna go in emergency mode. And it's gonna reverse until it's safe again. Hopefully. And if the distance is below 15 centimeters, and we have an emergency, then we're safe again and we can stop. So this is, yeah. Now we must not forget to actually initialize the code. Because if we don't call the measure function using set interval, nothing is going to happen, and the car is going to crash. It's a little twitchy. Let's put this in the initialize function. This should do it. Oh, I must not forget the most important part. Now, if this car crashes, having a flag on it is not, doesn't reflect my feelings about this country. Where should I put it? Let's just put it here. Oh, there's it. Right. Okay. Right. Yes. I'm a little nervous about this because I'm not really sure this will work. So when I tried this at home about 50% of the times it works. Right. The reason why it is so twitchy is because, well, the lights here are a little bit interfering with the sensor. So that doesn't help either. Yeah. It also depends a lot of grip. If you have a lot of speed, you need a lot of grip to make sure you don't run off the table, and this table is just... Okay, let's just try it. Oh, this is not good for my heart. This is terrible. Shall we do it again with a little bit more speed? This is just tempting the demo gods. This is just... Okay, this is enough. This is enough. And I'm not going to try backwards because there isn't a sensor in the back. But yeah, well. So this is just a lot of fun. Would I use this in production? No. No. This is really just fun to play with. And not only that, it is just amazing to use this for prototyping, for example, because you can create stuff really, really, really fast. You can create a remote-controlled car in 30 lines of code. That is just amazing to me. And if I were to do this in C, it would take so much more code and so much more time. The fact that you can then interface with browsers is, again, mind-blowing to me, because the web is so much more than just a static web page with some text on it. So I hope I somewhat inspired you to play with this a bit. As I said, I have 4 of these Nordic thingies with me, gracefully donated by Nordic Semiconductors. And if you want one, please come up to me. And I just have 4, so the first 4 people will get one. And with that, I want to say thank you.